Welcome to What's New in Siemens NX. In this video, we're going to be taking a look at the latest enhancements to additive manufacturing. And to take you through the demo, let's hand over to Ashley.
Hi everyone. So Paul's given me this really great topology optimized part that he sent over. It's for some sort of motor mount, gear mount, gearbox mount, that sort of thing for an automobile. And so we're going to print this part using aluminum and additive manufacturing. The problem here is that additive manufacturing is really accurate these days, but it doesn't always produce parts that are accurate within tolerance. And if you want exact surfaces within some really tight tolerances, then you often need to print your part and then send it on to a downstream machining step. And that's what we're going to do here. Now, to do that, I need to alter this geometry a little bit so that it has the material it needs for the post-print machining so that we can machine those parts away and get the exact surfaces we need. So I've got to print a part that's not exactly the part that Paul sent along, but sort of an interim version of the part. And then when Joe gets the part and does the machining, he will machine it back to the exact surfaces that Paul has designed. Now, the great thing about this particular part is that it came out of our new topology optimization system where we get actual faces inside the model. So I've got my selection here turned to face, and you can see that straight out of topology optimization, we've got things like these holes have actual faces and these planar regions are actual faces. So that makes it very easy for me to go through and do the modifications I need to do to get this part ready for printing. If I was doing this with geometry from some other topology optimization system, I would most likely be just sort of massaging facets. And anybody who's done that knows how terrible that is, even with a really good system. So in this case, we're getting really nice, clean geometry out with real faces I can work with to do my job easily and cleanly. And I'll show you how right here. First thing I'm going to do is take these holes down here at the bottom that are pretty large, and I'm going to shrink them a bit, give them just a little bit more meat so that when Joe comes along with his machining process later and drills those out, he has enough material to work with to drill it out and get the exact surfaces we need. So I'm going to go to my offset tool here, and I'm just going to select the face and tell it to automatically find the rest of the faces, and I'm going to bump those in by about 5 millimeters. So basically I just shrunk those holes with one step. It took me about 10 seconds in our new system, which is, again, if you do this with facets, this is just amazing compared to that. These top holes I'm just going to get rid of. They're small, and again, we need some meat up here, so I'm going to tell it to loose match those. It's going to find all 12. Those I'm just going to get rid of. We know where they're at. We know what the diameter needs to be. I'm just going to fill them in, and we'll have those ready for machining as well. The final step is down here on the bottom. We have these 4 sort of feet, and we want those to be all perfectly planar so that when we mount this in the car, it's not going to wobble, it's not going to torque and have any undue stress put on it. We want those to be perfectly planar. So again, we're going to build up those surfaces just a little bit and machine them back so that they're perfectly planar. I'll use the move command to do that, and I'm just going to pick each one of these faces here, and I'm going to move them up by about 2 mils to give us enough material to machine away. Hit OK, and again, this is all done. What has it taken me? 2 minutes maybe to make all of these edits. If you were doing this with a system where you had to just edit the facets, you would not be doing this in 2 minutes. This would be a project. So you can see how easy it is in our new system with the new topology optimization, the types of geometry it returns to get a part prepped for printing. The next step is to put that into a build tray, so I'll be back in just a minute and we'll do just that. So we now have a part that we've designed for additive manufacturing. We've manipulated the geometry. Now we need to put it into a build tray and get it set up for printing. So I'm going to go over to this part where I have basically an empty part. I'm going to select my printer, and then I'm going to add the part to the build tray. Now, I don't really care where this part comes in. It's probably going to be thrown out in space wherever it was in its native assembly at the moment. But I don't really care because I'm going to take that part and I'm going to run it through a new system we have for correcting for distortion. So one of the real problems with additive manufacturing, especially metal additive manufacturing, is distortion. Now that can throw a part out of tolerance. It can even cause failures within the print where you end up with a really expensive door stop. lots of these things can be mitigated by controlling the distortion that the part goes through as the little bits of metal and the different layers of the part are heated up and cooled down within the printing process. Now, a lot of distortion problems can be alleviated by orienting the part in the proper orientation. And we have a tool that allows you to do that called the NX Build Optimizer. Now, in the latest release of NX, we have integrated that tool into the NX system, and it's up here under the analysis menu. If you go to more and say thermal distortion, you can invoke this tool. Now, what this does is you pick your part, and the tool will take your part with a couple of characteristics you hand it here. It will upload your part into the cloud. It will run 100 different orientations of the part, running a simulation for distortion on each one of those orientations, and hand you back the orientation that has the least amount of distortion possible. And then you can move on to building things like support structures and all the rest of the things you need to do to print. But this is one way to really help the initial print quality for parts without having to go through some, really trial and error type operations that have been done in the past. So I'm going to go ahead and invoke this system. It's going to go run and do about 100 different orientations, and it's going to come back with an orientation for me. And then we'll do a few more things to it and get it set up for printing. So I'll be back in just a minute. So the system has come back, the AM Build Optimizer has come back, and it's given me this orientation as the orientation that it believes will give me the least amount of distortion. So now the last thing to do here is to create supports. Now I've gone over here in my support structure library. I've got a bunch of supports created here under this new support profile for blocks and cones and tree supports and all those sorts of things. And you can see that reflected over here in the dialog. Now I can do automatic supports, which we'll do here in a second. We also have the option to do manual supports where I pick the areas that I want. The system finds the areas to support and I pick which ones I actually want to be supported. I can do regions only where I make regions that are supported, or I can do automatic, which is what I'm going to do here, where the system finds the regions it thinks needs to be supported and supports them. So I'll select my part. I will get a preview, basically showing me these red areas down here where the part needs to be supported. And I'll say OK. And the system's going to go through and it's going to create support structures for my part so that when this part is printed, it's not going to sag or distort or have any effects of gravity on it, like you might see if you didn't support it properly. Now, it's not going to maybe support all of those red areas it showed me. It's going to do a further analysis once I hit OK, further analysis in the preview. So I may get a warning here saying that some areas didn't actually need support. Yep, just like that. But now we have a completely supported part. I can take this part, I can set up my build strategy for my printer, generate the actual print commands, send those to the printer depending on which printer type you have, all directly inside of NX. And sometimes, depending on the printer, again, I can also look at the build processor manager and open even slices to understand what each slice, what each layer of my print's going to look like, all from within inside the system, no STL files to drop, and all completely integrated from beginning to end.
Thanks for joining us. In the next video, we're going to be taking a look at the latest enhancements to subtractive manufacturing. We hope you enjoyed the video, and we'll see you in the next one.